I want to welcome everyone on the call or on the webinar to the WhiteSource CircleCI Orbs webinar. Basically, what we're going to do is go through the agenda real quick. I'll intro everyone into CircleCI Orbs, and then I'm going to cut it over to Shiri, who will then go over the WhiteSource products, and then also talk about how WhiteSource and CircleCI Orbs integrate and coexist with each other. And then we can do a quick or a short, quick, whatever, Q&A with whoever wants to ask any questions. That's where all the fun starts. So let's advance. Yeah, so let me introduce myself first. My name is Angel Rivera. I'm a developer advocate for CircleCI. And apologies for being a little late. It was just I'm at a conference. Everyone knows that conferences, so I had to rig up a phone, and we're doing this off of a tethered connection. Yeah, I'm a developer advocate for Circle, and my job is basically to go out and speak to all the developers, people in the community, get feedback from our user base or folks in the community, and then I liaise between again, the community and CircleCI. So I'm kind of a conduit, two-way conduit for information regarding the product, how people are using technology, what's going on in the technology world. And then I'm also explaining to folks how to use the product as well. Shiri, would you like to introduce yourself a little bit?
Sure. So my name is Shiri Vsan, and I'm a product manager at WhiteSource. Our goal at WhiteSource is to give customers and prospects the tools to actually manage their open source environments. So managing open source, both in terms of knowing which open source components you use, but also in terms of vulnerabilities, which we're going to focus on today, and in terms of licensing.
All right, sounds great. Yeah, so for those of you that don't know, I'll just go over CircleCI real quick. We're a continuous integration, continuous delivery platform that enables developers to build, test, and deploy their code using automation. Nothing, new there. But we're talking about today is Orbs. And for those of you that know how CircleCI works, we operate off of a configuration file. That's where you declare and define how your pipelines are going to be executed. And Orbs is a fairly new feature that we've released to our users, and what that enables you to do is take all of that YAML that you build in your pipeline and helps you kind of encapsulate that, right? So that gives you the ability to create these repackages of CircleCI configuration. And what it is basically parameterized YAML. So our system knows how to take YAML and then give you the ability to set parameters against whatever functions you declare. And I'll go over that in a second. But basically, it's a parameterized YAML that you can write and make things a lot easier, cleaner, and concise in your pipelines. Next slide, please. So yeah, this is a good example of the Orb. The Orb code itself, which is the stuff to the left, it's composed of three different elements, which are commands, executors, and jobs. The commands are the things that you want to execute in your pipeline. Executors are where those commands run. So it's a runtime environment. It could be Docker. It could be VM, Linux VM. It could be a Windows machine now that we've added that feature to our platform. And then jobs, which is the third element, are basically the way you lump all your executions and your execution commands together. So those are the three elements to an Orb. And if you look to the right or to the left, you can see the command is say hello, and then the parameter there, right? You just select or set the parameters, and then you build out a to function. So that's basically you're saying hello. And then if you look at the default, it's a string, right? And it could be the CircleCI username, but you can override that as well if you just put the string into the to command as a value. So in essence, again, this is an encapsulation of your YAML file, and it enables you to easily control like a one-stop shop, right? Control the pipeline and the elements within that orb, so that you can then just streamline that into your actual pipeline in the repo. Next slide, please. Yeah, and so what we've done at CircleCI is we created this registry, and what we have is the ability to give folks like WhiteSource and other partners the chance to build their orb, right, and maintain it, so that our CircleCI users can use the tools that they like to use, right, from these partners. So WhiteSource has basically built their own CircleCI orb, that enables their customers that use CircleCI to use their products within their pipelines really easily, which is what Shiri's going to get into a little bit later in the presentation. Yeah, so I know it's really hard to read here, but basically these are some of the documents and supporting content that we built for our users to use regarding orbs, right? I know you can't really click these, but what I'll try to do is have our people email after the webinar this particular information out to folks so that you can have this in your emails. If it's not already in there, I'm not sure if we've done that, but we'll get that out to you. Next slide, please.
Okay.
All right, turn it over to you.
Thanks. So one of the, as I already mentioned, WhiteSource deal with the open source world. So one of the most important facts is how people actually use open source and how people adopt open source. And this is something that we see in the last few years. We see almost all of the developers actually rely on open source components when they develop their software. So I think that the fact is that something like 80% of the code today is actually open source. And you can see that most of the developers are using open source components all the time. And with open source, we have, I think, three main challenges. So the first one is across the company to actually understand which open source components do we use. Do we have any standardization? Do we have any policies for that in terms of which open source we allow our developers to use and which of them we don't? The second issue is probably the licensing or the distribution of open source. So a lot of people think that because this is open source, I can use it in my software and then later on I can sell it, for example. So this is true for some open source components, but not for all of them. So licensing is a really important thing to actually be aware of when using open source and when choosing the actual component that you're going to use. So that's the second issue. And the third issue is the vulnerabilities. So this is something that we're going to focus on during today's webinar. So yeah, 80% of the code base is actually open source. We can see that from around 20 years ago and up until now, and this data is quite old, it's from 2016, we can see how open source actually developed. And this is a very interesting fact. And then what we can see is that with the fact that more developers and more companies actually adopt open source, also the number of open source vulnerabilities is rising. So these are the numbers in the last few years. We can see last year, we don't have yet the information for this year, but we can see that last year definitely was quite a big peak there. And we see that because as people and companies adopt open source, hackers or all kinds of people that are not necessarily in the good side actually understand that. And they are looking for a way to take advantage of that. So that's why the number of security vulnerabilities has been rising. And we see kind of the same pattern for this year as well, for 2019. But actually, it's not all bad. So for those of you who are familiar with the open source community, you probably know that people are very aware of security vulnerabilities, specifically the maintainers of all kinds of repositories, specifically big ones, are definitely aware of open source vulnerabilities and of open source security. So we actually get a rise in the awareness that leads to suggested fixes. So most, you can see the number here, the vast majority of reported open source vulnerabilities have at least one suggested fix once they are published. So this means that the moment that actually the vulnerability is published and hackers sort of can take advantage of that, you already have the fix in place. But what do you actually have to do? So you have to update your software, and you first of all have to be aware of that there is a vulnerability and that there is also a fix. So of course this process can be manual. Of course, I can go and look at my open source repositories, my open source components, and understand which of them is vulnerable, which of them has a fix. We've seen users working with tremendous Excel sheets for tracking components and tracking open source vulnerabilities. So this is one of the options. Another important note here is that a lot of the information is actually not indexed. So we and most of the people who are dealing with open source vulnerabilities are relying on the NVD or the CVE database. And WhiteSource also takes additional sources, around 30 additional sources for vulnerabilities, but let's speak for a second about the NVD. So over 86% actually appears in the NVD, but the data there is not really structured in a good way. So there is no real one suggested fix. The suggested fixes can be multiple, can be quite confusing to actually dive deeper and understand what is the vulnerability all about. Another thing that we have is transitive dependencies in open source. So think about you using a specific library, but that library uses another open source library that uses another open source library. So you may be vulnerable, but not directly. So a lot of times what we see is that the vulnerabilities are actually transitive. So this is another challenge in dealing with open source vulnerabilities. Now, our mission is actually to empower businesses to develop better software. And we do that by managing better their open source components and securing them in a better way. Of course, we don't believe in a lot of manual work. Most of the things that we do are automatic. So both the detection and the remediation are done in automated ways. We do believe that, of course, there is the shift left model. This is not a new thing. Most of you are probably familiar with it. But of course, the cost of actually fixing a security vulnerability or even a quality issue, if you fix it in the requirement stage, in the concept stage, it's actually a lot cheaper than fixing it after you release. And this is the same thing exactly when dealing with open source vulnerabilities and when dealing with software lifecycle. So for example, if we understand something, if we understand and we actually explore the vulnerability in the research level, right? I'm a new developer. I want to use a specific component. And now what if I had something like a Chrome extension that tells me if I can or if I cannot use this specific component. So this is the research stage. I can choose a different component instead of this one if this one has a vulnerability. So this is really shifting left in its best way. You can also, of course, detect vulnerabilities as part of your IDE or in your GitHub or, of course, in your CI/CD, which is what we're going to focus on today. And you can also understand what the vulnerabilities are in the image registry level, for example. So we definitely believe in continuous scanning and continuous security across all the different stages in the software development lifecycle. So some of the things that we see lately, and this is from last year, I think most of these, maybe some of these are also from this year. So we do see a lot of different vulnerabilities, and most of them have like three main aspects. So the first one is data integrity, or integrity of the software in general. So what we can actually see here is the Apache Struts vulnerabilities that is done by executing remote code. And this is not a new thing. We see that a lot. The second aspect is availability. So here we can see, for example, hackers that were exploiting Jenkins servers and were actually mining a cryptocurrency. Then we have the security protection, which is probably one of the most dangerous ones. So we've seen this in Kubernetes, for example, where people use a specific user and then they can escalate the privileges and actually get to a root user in your cluster. And this probably means that maybe they can get personal information of your customers. Of course, they can change things in the application. And this leads to very severe implications. So what can we actually do? And what do most companies that we see, what do they do? So there is the common way of actually dealing with vulnerabilities, and this is what we see sort of across the board. So we see the security teams that are analyzing and prioritizing the vulnerabilities. So they have this job of actually understanding which vulnerabilities there are, which vulnerabilities are being published. They're responsible for researching them, understanding the implications. And then what they will typically do is they will send an email or will open an issue or a task in Jira, for example, for the developer. And then they will say, okay, listen, this component is problematic. You have to upgrade the version. But the developer has a lot of other tasks to do, right? They want to complete their feature. They probably don't really care about this specific vulnerability that the security team just found out. So we see that closing the loop on the resolution or the actual remediation, whether or not the developer fixed the vulnerability, is hard. We see that across the board with almost all of our customers. And this causes a lot of tension and a big gap between the different teams, right? The security teams, they want the developers to remediate and they want them to deal with the different security vulnerabilities. Then we have the DevOps team sort of in the middle, because sometimes it's their job to make sure that the components are being updated regularly. But of course, the developers, they just want to get things done. They want to release new features. So there is a lot of tension between the different teams. And what we believe is actually that one of the things that we can do is to bake the security into the existing workflows. And I'll elaborate more on that. So we see that when we actually move the responsibility about the vulnerabilities to the DevOps team and to the development team, we see this gap sort of being a lot better. So what we basically understood is that we already have existing workflows. So for example, one of our workflows would be code review, right? Every time that I develop a new feature, I have someone from the team, maybe my team leader, maybe another colleague in my team, that is actually reviewing my work. So one of the things that we said, why don't we have security a part of the code review? Another important workflow that we have is building the software, the CI/CD lifecycle. And there, what we basically say is we already failed the build if we have a quality issue, right? If we have a bug, we will fail the build. So what we basically say is, why don't we fail the build also if we have a security issue? This makes a lot of sense. And now what I wanted to do is to actually introduce the Vulnerability Checker Orb. So this is a new orb that we developed. Initially, what WhiteSource had is just one orb that was for our paying customers. And now what we decided to do is to actually have a free vulnerability checker orbs that is available for all CircleCI users. And this actually identifies, so we have a list of the top open source vulnerabilities from the last month. So in this demo soon, we will see an example from July last month. And what we actually check is whether these vulnerabilities exist in your code. And that basically gives you a very simple report of which top open source vulnerabilities you actually have in your inventory, in your libraries. Then you'll see the vulnerable libraries and also their path. And if there is a suggested fix, a verified suggested fix, you'll see that as well. In addition to that, you'll see the reference links. So things like the GitHub issue that actually fixes the vulnerability. Maybe if there are some articles about these vulnerabilities for you to better understand the vulnerability, the implication, and deep dive on that. So we will also have that as part of the report. So what does it look like? Basically, this is the orb itself. So you can see this is a vulnerability checker orb. Basically, there is no specific parameter that you have to put, just the job, which is the vulnerability checker /scan. The default is that it will scan your local repository, so we'll see that in a second. And then this is just the first part of the report. So basically, in my example, we had 3 of the top July vulnerabilities in my libraries. So we can see 1 is high severity and 2 are medium severity. And then we can actually dive deeper and see the high severity vulnerabilities. What are the reference links? What is the suggested fix? So let's see how that works basically. So let's start with the orb registry. This is where you'll find the WhiteSource orb. So let's just look for WhiteSource. You'll see 2 different orbs here. So the first one is the vulnerability checker. That's the one that we're looking for. And then we have the WhiteSource scan, which is the integrates the unified agent. And this is for the customer. This is for paying customers. So what we can see is that this orb actually integrates the vulnerability checker with the top vulnerabilities. So all we have to do is to actually insert this orb and enter it as part of our repository. So for this example, I actually used GitHub. This is just an example, just a demo repository with a few tar.gz with a few jars. And I have my CircleCI configuration here. So you can see that I have my workflow with the vulnerability checker /scan. Now let's see what it actually did. So I went to this exact same repository. I actually performed a build about an hour ago. I just deleted some files. Before that, I added files. So what we can see is the actual report. Of course, you can always see the logs, exactly what happened. And then if we go to artifacts, we can actually see the results. So the results are just an HTML format of all the vulnerabilities that were found. Okay, so this is an example for a project where it actually found some vulnerabilities. Okay, so you can see that the analysis actually was performed successfully. Then we can see the libraries. So let's just close all of them just for the sake of this. So we can see 2 CVEs. So CVEs are actually based on the NVD database. And then we have 1 WS. So WS stands for WhiteSource. And this is actually a vulnerability that our research team found and is not found in the NVD. So what we can see is here, these are 3 of the top 50 for July. And then there is more. There are some older vulnerabilities. Maybe these were top vulnerabilities in June or in May or earlier this year. So everything is actually saved in you see all the vulnerabilities across the year. And if we just dive deeper into one vulnerability, so we can see that this is a vulnerability. Its CVSS score, the severity score, is 7.4, which means it's a high vulnerability. Then we can also see the exact path. So we can see that this is a Lodash library, and we can see also the reference. So for example, the reference would actually be the pull request with a fix. So if we just click on that, we'll go directly to GitHub. This will redirect us to GitHub, and we can see exactly what happened here. We can see that this was a vulnerability. So we can also see that this was upgraded, and we can see exactly the CVE, okay? So this is the CVE, this is the actual fix for that. And then you can understand better and dive deeper into the vulnerability itself. Now, let's take a look at another vulnerability just as an example. So this vulnerability, for example, is again another Lodash, and we have a vulnerability in the decompress.zip file. So for all of these, you will actually have the reference links. If there is a suggested fix, you also see it here. And there is an older vulnerability specifically found for Jackson databind folder. So we can also take a look at that. In this example, we also have an actual summary of the vulnerability and what actually happened in it. So this is also very interesting in order for you or developers to actually understand what was the issue within the actual release. Another important thing that I can show is an example for a project that doesn't have any vulnerabilities, right? So you'll still have under the artifacts, you'll still have the results, but you actually get a different one which says, okay, you're lucky you don't have any of the vulnerabilities, and then basically you know that you're good to go. Now, an important thing to mention is that we don't automatically fail the build if you have a vulnerability. So it's up to you to actually look and understand inside the artifacts and understand if there is an actual vulnerability or not. And then, of course, you can act accordingly. I hope this makes sense in terms of, the demo and how that works. So I'd be happy to answer any questions that you guys have. Anything that you have had, Angel, that would be great.
Yeah, no, so if you have any questions, just hit the QA button in the Zoom interface and just punch your question up in there, and we'll do our best to answer them. In the meantime, so I have a question while we wait.
Yeah.
So I saw that it's pretty awesome that you have, I saw that you have multiple references regarding, vulnerability notifications or like from the NVD, you have obviously a stream coming from there. And I saw that you're using GitHub issues as well.
Yeah.
How is that curated, just out of curiosity? Because that's a pretty awesome feature to have, being able to get feedback and input from different reliable sources. You know what I mean?
Yeah. So basically, we gather them both using automatic processes like different importers that are working online and getting the vulnerabilities and then getting the references. And also we have a research team. So for each one of the vulnerabilities that are actually being published, there is some manual work of a person that is working and getting some reference links, a security researcher or security analyst that will work on that and understand what are the actual reference links. And then also if there is a verified suggested fix, he will put it in the relevant tab. So not always we have a verified suggested fix. So sometimes it's a suspected suggested fix, but we didn't verify that it's working. So these are the two options.
Well, I like the fact that, you can knock down like 0 days You know what I mean? If you're having a lot of kind of sources of information regarding 0 day, you know, kind of lessen that time. Obviously, if you're aware of something, you have the opportunity to fix it quicker before it becomes a real problem. So it's pretty interesting kind of a feature that you guys have. I like it.
Thanks.
I don't see any questions.
Yeah, me neither.
So I don't have any more. So I guess we'll call it a day. So yeah, if you want to finish up with those slides.
Yeah.
I think both companies are hiring.
Yeah, that's for sure.
Go ahead, Shiri.
Yeah. So we're hiring, and let me know if you had any questions or anything doesn't make sense with the orb. We're definitely open for new features, new questions, anything that you guys have to add. And thanks, Angel.
I had one more question that I just thought of it.
Okay, go ahead.
So with the vulnerability checker, you said that you stated that you won't fail the build. Obviously, you won't exit one. So can we engineer that based on the or vulnerability checker, or you know, is there a flag we could add?
Yeah, so I don't think there is anything out of the box, but definitely that's one of our next steps. To actually fail the build when there is a security vulnerability. Yeah.
Understood. Yeah. It's a rolling release, right? Things get updated.
Yeah, definitely.
Yeah, just so you know, I actually used the orb in a demo. Well, it's like a video or something, but yeah, it worked really well. And I was trying to make it fail, but it wasn't hitting the top 50 of the month, so the stuff I had in there. But it worked, right? Like it ran through my code, and it was just some more to test it later.
Yeah.
But yeah, I guess that's it. Thank you so much, everyone, for attending, and we'll do it again sometime. Thanks, Sherry.
Thanks.